Hello again. Today we're going to be looking at this Greenlee DM-20. A friend of mine gave me this to play around with. I thought we would go ahead and take this thing apart, show you what it looks like on the inside. You can see here the leads are attached at the base. It's UL listed, made in China of course. One of the interesting things with the meter, if you look at the face, it has a 200 and a 300 volt range. And you notice the same thing for the DC side. I don't know who originally made the meter. I doubt it's Greenlee. I think what happened is Greenlee, when they rebranded this, derated the original manufacturer's numbers by 50%. My guess is the original manufacturer rates this at 600 volts. Little shield in the back. You can see it's kind of interesting. There isn't even a battery tray really. Battery just kind of squished in here with this foam. I doubt that's going to be picked up by the camera, but it says 315 milliamps, 250 volts. So at least the clips here have the side latches. Obviously this has been used, but the fuse is still intact, and obviously with the leads being directly connected to the circuit board, all that would have taken to blow that fuse is have this thing in one of the current modes and attach this thing to a high current source, and that would have been it. Obviously the current input was never really used on this meter, or it was used correctly. See a rotary switch, a couple of ball bearing detents. Wow, that's quite the switch. There's a lot of copper on there. So you got R27 here, which appears to be a 10K. It routes up into the rotary switch, and then we have a PTC here. Again, going up into the rotary switch. Normally you're going to see some kind of a back-to-back for a clamp. My suspicion is we're going to see a lot of breakdown in this area. So the board has a marking, let's see, 280904-D. And again, DM-20. Let's have a look underneath here. I would assume this pot here is for some kind of alignment. There's a DM-20 280904-D. There's an SL logo with a E234156 SL-D, and then there's a 94V-0. I don't know who made the meter originally. Be kind of interesting to know. I suspect this cost about $20 or $30 brand new. This one's in very good shape. You can see the oxidation along the piezo. Okay, we'll just start with some real basic functions here. That meter's display is very small. Okay, so this is on the 2 meg input scale. So I'm assuming that this cannot read a 10 meg ohm resistor. Yeah, it cannot. Let's try a 1 meg. And there you go, 1 meg. Looks very close. Let's try 100K. 10K. 1K. Let's try it on the 200K scale, and this will be 100K. 20K scale, this will be a 10K. Pretty much spot on. 1K. This will be the 200 ohm scale. This is 100 ohms. I don't know why it wanders like that. Let's try 50. Yeah, it's like it's got a lot of noise on it. You know, I can't like just swap the leads out because obviously they're integrated with the meter. Let's try it with a dead short. Boy, look at that thing move. Continuity test. Again, very long release and not very loud. Using a 50% duty cycle I measured the maximum frequency and it's greater than 10 kilohertz. So this meter is on par with a few of these. It's very fast. The pulse width detection limit is sub 5 milliseconds. Again, picks up a very short pulse. What's interesting about this is this short circuit detection resistance. 500 k ohms. Yep, that's right. It opens at 520. I have no idea if there's a problem with the meter. It seems to work. So if we look at the open circuit voltage, it's on par with a lot of meters. It's basically a volt. What's interesting though is when we look at the short circuit current, most of these meters will run about 200 to 300 microamps. You know, one of them was up near a milliamp, a little over a milliamp. But, you know, this thing here is like sub 10 microamps. It's like, you know, 10 times lower than the lowest meter I've seen. Yeah, I don't know why such a high impedance and such a low current for a, you know, continuity tester. I assume that that high impedance is somehow making the meter more robust. That would make sense to me, but yeah, I don't know. Let's try the dial check. This will be a short. Looks fine. Here's a single diode. Wow, is that right? Yeah, that's one diode right there. This thing cannot pick up a single diode. Yep, I'm not kidding. It cannot read a diode. Maybe a Schottky? Let me see what I've got here. This will be a Schottky diode. If I touch the leads together, 0 volt. But for diode mode, it cannot pick this up. It goes down to a 200 microamp range. I never test the current on these. We'll go ahead and try this out with a DC source. These are just some adapters I use from time to time to adapt the probes down to standard banana jacks. This is with a 10 volt signal applied. This is in the 200 volt range and the 300 volt range. It's funny because the see the little lightning bolt comes on in the 300 volt range. This will be 1 volt. The meter on the right is a Syntec P98674. This is sold by Harbor Freight. It's a rebranded Mastech MS8268. Both of these meters are rated for 2,000 counts. This meter is about $50 if you use a coupon. The Greenlee, again, $20 or $30. I don't believe this meter is actually sold anymore. So this is with 1 millivolt applied, and this is in the 2,000 millivolt range, or I'm assuming 2 volts. So again, if I put a volt into it, expect 1,000 counts, no problem. We'll set it on the 200 millivolt scale. This meter is pretty much dead on. This is roughly a 5 volt 60 hertz sine wave applied. There's about 0.4 of a volt discrepancy between the two meters. It's in the 300 volt scale. And again, I believe that's probably originally a 600 volt scale. This Greenlee doesn't read frequency or duty cycle, so we can't test any of that. There's no capacitance. Alright, for this next test here, I've got the high voltage power supply out. Again, this meter is rated for 300 volts max. We'll start on the 200 volt scale. And you can see it overflows right there. So this will be the 300 volt range. Of course, the high voltage symbol comes on. So there's 300 volts. Yeah, I suspect this thing is, again, was actually designed for 600. Let's just see here. There's 400, 500. And 600 volts right there. See, the meter is actually quite accurate there. 603, 604 volts versus 607. They definitely meet what the meter's rated for, the 300. But again, I think it was probably derated by Greenlee. Otherwise, I can't explain this 200 and 300 volt range. That doesn't make a whole lot of sense to me. For our next test, we're going to run our static discharge. Again, I'll give it 5 transients, positive and negative, and let's just see what happens here. For the next set of tests, we'll have our transient generator out, and we're going to be applying a 220 volt rectified AC signal, and we'll do that with each mode of the meter other than current. It's at 520 volts. Yeah, I think it's kind of confused by the waveform. We'll have to be careful here because it does have a good fuse in it. 230 volts DC over range. Yeah, I don't know what that means. Alright, let me go ahead and functional test this thing. Okay, the Greenlee DM-20 passed that test with no problems at all. Just an FYI, the TechPower TP2844R failed that test. For the next set of tests, we'll be running our transients. So again, we'll be running 1 kV, 100 microsecond full width half height, 2 ohm source impedance. We'll be doing positive and negative transients with all modes of the meter except for the current. Okay, that's it. We'll go ahead and functional test it. The Greenlee DM-20 passed that test, 1 kV. The meters that failed the 1 kV test were the BK2705B, the UTL DM-2, the Southwire 12070T, and the Innova 3320. So the Greenlee's off to a pretty good start. So again, this will be 1.5 kV, 2 ohm source impedance, 100 microsecond full width half height, 5 transients, positive and negative, each mode. Alright, that's it. We'll go ahead and functional test it. Alright, so that was 1.5 kV. The meter passed just fine. So just for a reference, so the Amprobe AM530 had failed at 1.5 kV along with the TechPower TP40. So again, this will be 2 kV, 100 microsecond full width half height, 2 ohm source impedance, 5 transients, both positive and negative. Alright, that's it. I'll go ahead and functional test it. Yeah, I'm sure Chris is going to be quite surprised with this, but his Greenlee DM-20 passed at 2 kV. The Klein Tools MM2000, however, failed at that level. Next, we're going to be running 2.5 kV, 100 microsecond full width half height, 2 ohm source impedance. Again, 5 transients, positive and negative. Oop. Let's just turn on the line voltage. Yep. You saw it break down though. I think we're on the verge here of failing. Alright, I saw a few arcs this time, so hopefully here the meter's still okay, but I think we're getting close to where it's going to fail. Well, unfortunately it's failed. It's in resistance mode here, and you can see it's reading a short. Put continuity mode, we get a short. Dial check, short. Okay, looking at the board, there's this Q1 up here that seems to be configured as maybe a diode. It's marked a S9013, and that, I believe, is shorted. I'm just going to pull this thing out real quick with the soldering iron here. Okay, it was just a 9013 or whatever I said it was. It's just a small signal transistor, or 500 milliamp. I think it was like a 20 volt part. Let's see here if it works. So this will be 1 meg resistor. Yep. And a 100K. Yep. 20K. Or 10K. Yep. 1K. Yep. 100 ohms. Yep. Yep. And diode check. Okay. Looks fine. What I've done is I've set the meter to the 300 volt AC range, and we're going to set the transient generator for 4,000 volts, and let's just see if the meter will handle this. Well, something's breaking down in it. Okay. Let's see what happens here. So this will be a single transient with the half cycle line simulator attached. Again, we're going to be supplying the meter with about a 4,000 volt peak, and that'll have a full width half height of 100 microseconds with a 2 ohm source impedance. This will trigger our secondary generator. Assuming the meter breaks down, the second generator will hopefully feed the energy into the meter. Secondary generator is rated for about 400 joules when I turn it up all the way. There you go, Chris. Wow. Look at the smoke coming out of this puppy. Jeez. Holy smokes. Can't imagine having something like this in your hands and having it cut loose on a real line. You people who are real electricians, I got a lot of respect for you. It's not a job I would want to take on. Wow. I'm not so sure that this here, I think that's a copper trace. Look at that switch. Wow. Yeah. Like I said, it's about 400 joules to do that kind of damage. Let's see what this looks like. Yeah. That's that trace right there. So it went all the way from here, all the way around. That right there is that trace. Maybe if we went to another mode, it would probably take out another section of the switch. Maybe more severely, but boy, you can really see the damage up in here. So these are the test results for the Greenlee DM-20. So again, the meter passed the piezo grill igniter test. And while the meter was only rated for 300 volts, we went ahead and took it to 600 just for the fun of it. And it survived that just fine. And again, I believe that Greenlee bought that meter from somebody else and had derated the high voltage by 50%. And that's how they came up with the 300 volt range. Otherwise, I can't explain why you would have a 200 and a 300 volt range. That just makes no sense to me. Anyway, so it survived that just fine. And then we tried our rectified AC test. It passed that just fine. And then we started our surge testing, and we went all the way up to 2 kV. And as we can see here, quite a few meters have actually failed before this meter. This one here, this is the Fluke 87V. So the ANOVA had failed, the south wire. This one's the UTL, the circuit test. This is the BK. Up here we have the Tech Power TP40. This is our Amprobam 530. And up here we have the Klein Tools MM2000. So this meter has actually held up quite well. Chris, you're probably pretty pleased about that. It's not like bottom of the barrel. I really didn't think it was going to get this far, just looking at the circuit board and how dense that switch was. Of course, that switch lit up in the end. Anyway, I hope you enjoyed the video. Till the next meter.